Cold showers, and similarly cold water dipping, have become popular on social media over the past few years, with many users sharing their experiences with and the perceived benefits of these practices. The alleged advantages of cold water exposure in this way include higher energy levels, better concentration, and improved mood. But what is the scientific basis for this? Brief cold water exposure is known to increase the amount of noradrenaline in the blood. This neurotransmitter has an important role in arousal and vigilance, so it is not difficult to imagine how a cold water dip may be beneficial for energy levels and concentration. However, it is important to remember that changes in neurotransmitter levels in the blood may not reflect the same change in the brain, as these molecules cannot cross the blood-brain barrier, and they are synthesized in the brain separately. So, as opposed to measuring neurotransmitter levels in the blood, it is more beneficial for these types of questions to measure performance instead. The ability to concentrate is one of the many results of what cognitive neuroscientists call executive function, the ability to plan, organize, and modulate behavior. Thus, tests of executive function and cognitive performance can serve as an indirect indicator of how concentration may also be affected. Many of the studies involving tests of executive function and psychomotor performance have not found remarkable improvements after cold water exposure. In fact, many studies have found a reduction in performance following cold water treatment, as measured by increased error rates or slower reaction times. However, it is important to note that many of these studies have implemented long cold bath regimens, which may not be comparable to the practice of a cold water dip or a brief cold shower. The body's first response to cold exposure is constriction of blood vessels in the skin to slow down the loss of body heat, but prolonged time spent in cold environments will eventually cause core body temperature to fall. Thus, brief cold water exposure may not have the same detrimental effects on performance if performance is affected by the loss of body heat caused by prolonged exposure to cold. This study adopted a 5-minute, 20-degree whole-body bath and measured the participants' mood and brain activity before and after. Participants felt more alert, attentive, proud, and inspired, and less distressed and nervous after the 5-minute bath. These improvements in mood were associated with changes in activity between brain regions and networks involved in attention control and emotion. In another study, 3 weekly cold water exposures into 10-degree water for 10 minutes at a time were found to reduce sleep disturbances after 2 weeks. Improved sleep quality could serve as a mediating effect to benefit cognitive performance. Participants also produced lower scores on the Penn State Worry Questionnaire after the first cold water immersion and in weeks 2 to 4 of the study. Researchers found no detrimental effects of the cold water immersion on the Stroop task, where participants need to name the color a word is written in and not read the word itself. Additionally, participants were faster at completing the trail-making test over the course of the study, although some of this may be due to participants learning how to complete the task better due to familiarity. So, while the potential benefits of cold water exposure on cognitive performance are not clearly defined in scientific research, a brief cold shower or bath does not appear to be harmful either, and some studies do state effects which could be beneficial for everyday life. But what do you think about this? Would you try a cold morning shower based on these results?